All right, so we're going to be talking about basics of functions and their graphs. And before we discuss functions specifically, we want to set up a few definitions. So first we've got a relation, which is a relationship between two sets of values. So I think of this as just anything that can be put on an XY axis, a two-dimensional graph. So if you're looking at your XY axis, just a set of discrete points is an example of a relation. A circle is a relation. This thing, this squiggly thing, blah, that's a relation. So anything we can put on a graph is considered to be a relation. Not all of these are functions, but they're all relations. And for a relation, we can define the domain, which is the set of x values, also considered the input values. And we can define the range, which is the set of y values, also called our output values. And by the way, if you ever find yourself getting domain and range confused, which is which, domain is your x values, range is your y values, and luckily they're both in alphabetical order. X comes before y in our alphabet, and D comes before R in our alphabet, so that helps me keep them straight. All right, so one type of relation we could look at is a set of ordered pairs. So looking at the relation in number 1, we have the relation that's the set of ordered pairs 0, 2, 1, 2, 1, 3, and 2, 3. And suppose that we want to state the domain. So the domain is our set of x values, and we're just going to be looking at the x values in all of our ordered pairs. So we've got 0, 1, 1, and 2. Whenever we write a domain or a range, we're going to write it in what's called set notation, which are these squiggly braces. So our domain will be the set of all of our x values, so 0, 1, and 2. And notice that I don't write repeats. So even though we have 2 1s, we only write 1 once in the set. All right, and for our range, pick a different color. For our range, we're looking at our y values. So we've got 2, 2, 3, and 3. So our range again will be in set notation. We're not going to write repeats, so it's just the set of the numbers 2 and 3. All right, so a function. A function is a type of relation in which every input value is paired with only one output value. So each input, x, should produce exactly one y value. It can't produce 2 y values, then it's not a function anymore. So down here, I wrote the question, is it a function? And we're going to ask this question a few times going forward. There are different ways that you can see a relation expressed. One is as a set of ordered pairs. So if you're asked, is this a function, and you're given a set of ordered pairs, the way that you can figure out if it's a function is if you have repeated x values, then it's not a function. If you have unique x values, then it is a function. So looking at number 2, I'm just going to focus on my x values. I have the set of the ordered pairs 0, 2, 1, 2, 2, 3, and 3, 0. So looking at my x values only, 0, 1, 2, and 3. I have unique x values. I have all unique x values. There we go, I can write. Unique x values, so that means, yes, this is a function. Where if we take a look at number 3, I have x values 1, 1, 2, and 3. You can see that I have a repeated x value of 1. There's a 1 here and a 1 here. So that means in number 3, this is not a function. So if you're given a set of ordered pairs, you're just looking for repeated x values. By the way, I want to point out, going back to number 2, which is a function, notice that we have repeated y values of 2. That's totally fine. Okay, so repeated y values, not an issue. Don't care. All that we're looking at is whether we have repeated x values. And if you guys remember the vertical line test, which we'll talk about more formally in a few minutes, if you guys remember the vertical line test, we could also apply this, and that relates to this idea of repeated x values. So for number 2, if I were to graph that relation, I have 0, 2, 1, 2, 2, 3, and 3, 0. And if I were to try to draw a vertical line and hit my relation twice or more with one vertical line, I couldn't do it. Each vertical line hits at most one time on my relation. So that confirms that we do have a function by the vertical line test. If I were to graph number 3, 1, 2, 1, 4, 2, 3, and 3, 0, if I were to graph that, you can see right here where I have the repeated x equals 1. One single vertical line hits my relation twice, so that means that it's not a function by the vertical line test. All right, and that's because we have those repeated x values. Okay, so we can also be asked if we have a function if we're given an equation. So if you're given an equation for a relation and you're asked, is it a function? Your first step is to solve that equation, excuse me, for y. And then looking at the equation after it's solved for y, if one x value, if one input value can produce 2 or more y values, 2 or more outputs, that means it's not a function. All right, so in the first example, we have 2x plus 5y equals 9, and we're wondering if that's a function. So we solve this for y. First, we subtract 2x from both sides, divide all sides by 5, and we end up with y equals negative 2x plus 9 over 5. Or if you want to write it more in that slope-intercept form, negative 2/5 x plus 9/5 would be fine too. Either form is fine. All right, so we've got this solved for y. And now I want you to imagine plugging any x value in. So just because the math is easy, let's imagine plugging in an x value of 0. So if my input value is 0 for x, I would end up with a y value of 9/5. And it doesn't matter that it's 9/5, it just matters that there's one of them, right? There's only one y value. And no matter what x value I plug in, I'm going to get exactly one y value, right? It might be an ugly fraction, but it's just going to be one of them, right? So no matter which x value you plug in, you're only going to have one output, one y value. So that means this is a function. Now looking at our next example, is x plus y squared equals 3 a function? So first we subtract x to get y squared equals 3 minus x. Then we solve for y by taking the square root of both sides. But when I do this, remember that square root property where you have to put your plus or minus there because we have a squared variable. When we take the square root of both sides, we use that plus or minus technique. So if we think of plugging in, let's see, we'll make a pretty number, x equals 2. If we plug in x equals 2, then y would equal plus or minus square root of 3 minus 2, which is plus or minus square root of 1, which gives you plus or minus 1. That's 2 y values, right? So that means if we were to graph this relation, I would see the ordered pair 2, 1, and I'd see the ordered pair 2, negative 1 on my graph. So again, we're going to have these repeated x values paired with different y values. One input value of x produces 2 or more y values. That means this is not a function. Okay, and I will warn you guys that this y squared is going to be a culprit of this. When you see y squared in your equation, whenever you go to isolate y, take the square root of both sides, you're going to end up with this plus or minus. So keep an eye out for those y squareds. X squared, totally fine. Not worried about x squared, but y squared is going to cause an issue. All right, and now we're getting to that vertical line test that we were talking about earlier. So if we're asked, is it a function, and we're looking at a graph and asked if the graph represents a function, for the vertical line test, if one single vertical line hits 2 or more points, then the graph is not the graph of a function. So on the left, we've got this parabola. Any single vertical line is going to intersect our graph only at one point. So we've got a function. Where over here to the right, we've got a sideways parabola. If I draw a vertical line, I'm going to hit my graph 2 times. This means I don't have a function. And again, the reason that this is failing is I actually have repeated x values all over the place, right? So I have those repeated x values again. So that's confirmed by this vertical line test, so not a function. All right, so let's take a look at numbers 4 and 5. Are the following graphs functions? For number 4, I could draw one vertical line right there. I'm going to intersect my graph there, there, and there. So no, 4 is not the graph of a function. It's not a function. Where for 5, anytime I draw a single vertical line, I can only intersect my graph once. So yes, this is a function.